In this video, we are going to look at the substitution rule for indefinite integrals. We have e to the power negative 6z, and then we have sine of e to the power negative 6z. The idea here is that we know some integrals, like for example, we know how to integrate sine and we know how to integrate cosine. And if we can convert an integral that does not look like the one from the table which we're supposed to memorize, then we are doing the substitution, right? So in this case, what we want to do is look at the argument of the sine. Like if you're wondering, what do I put? If you have parentheses, usually whatever is in parentheses, that's going to be your u that you denote by, okay? So here we have e to the power negative 6z. Now let's take the derivative, okay? So derivative of e function, remember e function stays the same, right? If I had e to the negative 6z, it cannot change. It's going to stay the same, but it's not just e to the x or e to the z, then it would just be e to the z. But what about that negative 6? So what do I do with that? So the rule says this is really chain rule. What you're doing is you're saying, okay, e to the something is the same e to the something is the same something, but you need to multiply by the derivative of the something. Derivative of negative 6z, well, negative 6z is a line, okay? And derivative of a line is a slope. So this is just going to be negative 6, okay? So negative 6 is going to jump to the front, but the e function is not going to change. You're just going to write it over here. The other thing that you need to understand is that this du thing is not derivative of u. It's really differential. So if you're wondering what's the difference, well, the difference is the differential, the d, has to have a d there. Okay, so if you have du on the left, you have to have d something on the right. Well, what's the something? Well, what letter were they using? If they were using x, this would be dx. If it was y, dy, but we have z, so this is going to be dz. And why is that important? Well, because when we are switching the integral from z to u, we have to convert everything. You cannot just translate one part of the integral but leave the other one intact. That's not going to make sense, right? You can't have a mixture. When you're translating from Russian to English, you cannot leave half of it untranslated, right? Because people will be like, what? Okay, so what your goal is to convert the new integral to have only u only. Okay, so let's see how to do that. So you've got e to the negative 6z. We're going to write that for now. Then this is going to become sine of what? Well, I just said u is e to the negative 6z. So this is going to be u. I could have actually made this whole thing u, but I don't need to because we're going to see that in a second. But you could. It's not a problem. Well, what about this dz? You have to also translate it into u. Well, how? Well, that's because you have this equation right there. So you need to solve this for dz. You want to isolate dz by dividing both sides by what? Well, by that negative 6 e to the negative 6z. So you would get then du divided by negative 6 e to the negative 6z. Okay, and now you convert it, you translated dz into the u stuff, okay? However, we still have a mixture. We have a z over here and we have a z over here, but luckily for us, they cancel. Now, if you're wondering what happens if they don't cancel, then that's when you start crying, okay? Because if you can't do it, then the substitution rule doesn't work, or you don't know how to take integrals or derivatives, or one of those. Okay, but if they said use substitution rule, then it better work. Okay, so what's your next step? Well, next we actually got an integral that we already know. We have sine of u du. Except we do have this negative 6 right here, which nothing happened to that, right? We canceled the e, but the negative 6 we didn't cancel. So we need to pull it out. We can always pull a number outside of the integral. Never put anything that has variables. You cannot do that. But a number, sure. It's called constant multiple rule. So negative 6, if I pull it out, can I just pull it out like this? No, because the negative 6 was on the bottom. When you pull it out, it cannot just jump to the top, okay? So you're really going to have negative 1 over 6. Okay, next is go ahead and just integrate. Well, we know that integral of sine is negative cosine. How do I know that? Well, imagine that I forgot, that I just said, okay, well, I think it's going to be cosine or maybe negative. Now, remember, when you take the derivative of anything that starts with the c, which cosine starts with the c, the sign changes. If I leave this as a minus, then the sign does not change. So that's not right. Okay? And that'll hopefully give you pause and say, okay, well, no, integral of sine is negative cosine, right? Okay, so the sign will change and I will get plus 1/6 cosine u plus c. The last step here is just like backwards translation. So you started with Russian, you translated it to English, and then you have to translate whatever they said back. So now you have to translate this back to z. And, well, what u was e to the negative 6z, we're going to go ahead and substitute that. And then that's it.